Hello, my name is Chase Meltzer, and today I'm going to be teaching you guys how to use a test cross to determine the genotype of an unknown parent. So starting off, some key vocabulary terms to know. A genotype is the DNA of an organism determining a specific trait. The phenotype is the physical representation of this DNA. A Punnett square is a graphical representation of the various genotype possibilities for the children given the parent. And a test cross uses a known homozygous recessive parent and the genotypes of the children to determine the genotype of the other parent. So to start by looking at an example of a Punnett square, in this example I chose the letter F to represent my trait, capital F being the dominant trait of having freckles and lowercase f being the recessive trait of not having freckles. So in this example, I said that my mom was heterozygous and had freckles, and the dad was homozygous recessive and did not have freckles. So you can see, using this information, we know that the dad would have one gamete of the lowercase f, and the mom would have two gametes of the uppercase and lowercase f. Using this information, we can make our Punnett square and determine that any offspring will have a 50% chance of having freckles and a 50% chance of not having freckles. So now, how do we set up and use a test cross? So test crosses are set up by crossing a known homozygous recessive, so two lowercase alleles, or alleles as they would be represented in a Punnett square, with a heterozygous parent and a homozygous dominant parent to compare and see which one could produce the offspring of the couple. Okay, so let's practice. So to determine the genotype of the other parent by performing a test cross, here we see this is our unknown parent. So we're going to want to start by, let's see, is it a heterozygous parent? So we're going to start by setting up our other Punnett square as heterozygous. We see that it couldn't be heterozygous because in this instance, making the other parent heterozygous produces two recessive offspring, which we see here our children do not have. But when we do the homozygous dominant, it works and we see our offspring. Here are my citations. Thank you.